6, applications of linear functions. That just means we're essentially looking at word problems. I am going to be very picky about what you have to do when you go through these problems. So there are some guidelines. This is written on that handout that I post on Classroom as well, but you might want to jot it down so you kind of know. The things I expect, you have to identify your variable. If you are solving a problem and it has x in it, I have to know what x is, because a lot of these problems, there might be more than one unknown, and I have to know what's what. So that's one point. If you don't know how to do anything else on a problem, if you tell me x is whatever, you get a point for that. Likewise, if you get the right answer, but you never told me what x is, you miss a point automatically. Second thing, express the other unknowns in terms of the variable. So, we can't have x and y in the same equation and be able to solve it. So we only want one variable at a time, so if there's multiple things we don't know, we'll put them all in terms of one variable. Third step is set up a model, or that's like writing your equation. Then we will solve and check our answer, make sure it's reasonable. And really there's a fifth step. I want you to answer with a sentence. If I give you a problem in words, I want you to answer it in words. So please write a sentence at the end. That's another easy point. Maybe you got the whole thing totally wrong, but you told me what x is and you wrote a sentence at the end, you'll get 2 points, even if everything else is wrong. So let's look at a problem. If the length of each side of a square is decreased by 6 centimeters, the perimeter of the original square is 8 less than 3 times the perimeter of the new square. What's the length of the side in the new square? Everybody knows exactly what to do, right? Yeah, no, you guys don't even know what I just said right there. So don't read it like that. Don't just try to read through the whole problem and expect to just have a light bulb come on and know the answer at the end. Take it step by step. So the first thing, if the length of each side of a square, so stop right there. What do I have?
Square.
A square. So what should I probably do?
Draw a square.
Draw a square. Is decreased by 6 centimeters. What just happened to my square?
The size is shrink.
The sides shrank. It got smaller. So I have a smaller square. All right. So this is my old square. This is my new one. All right. Do I know how big the sides were in my original square? So what could I call them? It's a square, so every side's the same. All right, that counts as defining your variable by labeling it in a picture. You don't have to necessarily tell me in words as long as it's labeled. So we've done the first step. Second step, I want everything in terms of the same variable. I don't want to come over here and say the new square is y.
X minus 6.
Right. I took the side and decreased it by 6. That means I subtracted 6. So the new one is x minus 6 on each side. So that's the second step. I put everything in terms of the same variable. Third step, we're trying to write an equation. So let's go back and read it. So it says the perimeter. What is perimeter?
All the sides.
Add up all the sides of the original square. So the perimeter of the old one. So if I add up all the sides in the old one, x plus x plus x plus x. You could also just write 4x. Is means what? Equals. So this equals 8 less than. What does less than mean? Subtraction. So does that mean 8 minus or something minus 8?
8 minus.
Something minus.
Something minus.
Yeah, less than flips the order, so it puts the minus 8 on the end. The perimeter 3 times, so 3 times something, the perimeter of the new square. So how would I get the perimeter of the new square?
4x minus 3.
Okay. So you could write x minus 6 plus x minus 6 plus x minus 6 plus x minus 6. Or you could realize there are 4 of those sides and they're all the same. So you could just multiply the x minus 6 times 4. So we have 3 times, then the perimeter of this would be 4 times the x minus 6. Or you could just write it out 4 times.
So you can write it for x minus 3.
That's fine too. Alright, so is everybody with me? Now this is an equation we can solve. So if I distribute that 4, that's 4x minus 24. Distribute my 3.
Everyone too.
Gage?
Yes, gang.
So if I subtract over my 12x, divide,
I'm good. I got you, Grant. Give me one.
He has to, he already has
what
one.
would they do without you?
Friday, he already has one.
No, it's not on my Grant.
I just told him to get up and get it done.
Good, that is a good move away.
Okay,
Have
People
a
were
grip.
helping easy to finish.
so I worked this all out, and I got x to equal 10.
Centimeters.
You guys all agree with this?
Yeah.
Yes.
I guess.
Once a cripple plays.
So, we are not done. Make sure it's reasonable. You know, if you had gotten a negative answer, would that be possible here?
No.
No. So check for any big errors like that. Then I want to answer in a sentence. The question says, what is the length of a side in the new square? So if x is 10,
X minus
4.
6.
x minus 6 is 4. So the side in the new square is 4 centimeters long. You guys can all write sentences. I expect capital letters, periods. No, use units. Don't just say 4. Tell me the 4 centimeters. Give me a good sentence at the end that clearly answers the question. All right.
Half my page.
Half your page?
How?
That's a good problem. So, what questions do you guys have for me here?
Oh, 0 times separate top. You can write that one stuff.
Was that as painful as you expected for a word
Yes,
problem?
Yes.
Well,
You
yeah.
guys are so dramatic.
Keyword columns.
It gets so much
They're
worse
not that
though.
bad. We can do this.
This is gonna make me fail this class.
Oh, it is not.
No, I swear.
It's 1 week of your life. We can do it.
Word problems.
I could define your whole grade.
By the time we get to the end, you guys will love word problems. You'll be begging me for more.
But she was passing the same thing last year.
She said that 2 years in a row.
You lie. I'm still waiting.
Okay, so a rental car company charges $20 per day and 30 cents per mile for renting a car.
It's kind of cheap.
It is cheap. Janice rents a car for 3 days and her bill comes to $72. How many miles did she drive? Can I draw a picture on this?
No.
No, that doesn't even make sense. So the first step, we have to define the variable. Your variable is what you're looking for. What question did I ask you?
How many miles did Janice run?
So pick your favorite letter,
M.
M. And what is M?
Miles.
The number of miles. Okay, is there anything else I don't know in this problem?
The amount of, never mind.
No, that's my only unknown. So step 1, identify the variable. I did it. You got a point right there. Step 2, there are no other variables. So we're ready to go to step 3, writing an equation. So they charge $20 a day. How many days did she rent it for?
30.
So what should you do?
60. 3 times 1.
Yeah, your $20 times the number of days. And, so what should we do?
And
What?
30 cents per mile.
So
30x.
30 in.
3N.
Oh, I did x.
Wouldn't it be 0.3 in?
Yes, why?
It's 30 cents.
This is $20, this is 30 cents. So we need 0.3 M. Equals, the total cost was?
$72.
All right. Bless you.
Now we solve for n.
Subtract over the 60. Divide by 0.3.
40. G.
So, the answer makes sense. We just have to answer in a sentence. The question was how many miles did she drive? So,
40 miles.
is that one okay?
Yeah, that goes.
The next one has a little more to it. I want you guys to take a few minutes on your own, read the question, and just see if you can draw a picture to match this.
No.
Okay, so Al paints with watercolors on a sheet of paper, 20 inches wide and 15 inches high. So everybody drew a piece of paper?
Yeah.
No, I don't, but.
Alright. And it is 20 by 15. If you have it flipped the other way, it doesn't matter, as long as you have it labeled.
Are you ready?
Okay, he then places this sheet on a map so that a uniformly wide strip of the map shows all around the picture. What does that mean?
The map showing the same on all 4 sides.
You want to mat it, so your mat has to be bigger than your picture, and you're putting that piece of paper behind. So there's my picture, I'm putting a bigger one behind it, so I have a border showing. So, let's draw the map. Oh, that is crooked. Don't judge me.
This is his first setting on the map. He hasn't centered it yet.
Okay. So that a uniformly wide strip of the map shows all around the picture. What does that mean?
It's the same length on all 4 sides.
This strip is the same all the way around. Okay. The question is, how wide is the strip of the map showing? So that's what I'm trying to find. So that would be my X.
Did it.
Alright. So now we can look at, we need the perimeter of the mat. So the mat is this red one. Perimeter, we have to add all 4 sides, right? But I need to know what these sides are so that it can equal 102. So the picture itself is 15. How far is it from here to here?
X.
That's X. How far is it from here to here?
15.
How far is it from here to here?
X.
So all together, how long is that side?
2x plus 15.
You have the 15 you started with and you add an X on each end.
So visually.
Okay. So for this piece, How far is it from here to here?
X.
Not from here to here. And then from here to here. So all together, that side is
2x plus 1.
okay, so for perimeter this time I can't just say 4 times it because not all 4 sides are the same. You're welcome to write this out. That side's 2x plus 15, this one's 2x plus 20. Moving around the rectangle, this is another 2x plus 15. That's another 2x plus 20. What would be a shorter way of writing it?
2x plus 15, 2x plus 20.
You have 2 sides that are 2x plus 15, and 2 sides that are 2x plus 20. So, 2 ways of writing it. It's just however your mind works, whatever makes the most sense to you. So if we distribute, add like terms. Subtract over the 70. Divide by 8. And get 4. Just as a word of warning, you don't have to get nice, pretty answers. You can have decimals or fractions. Okay, there's no rule that says it has to be a whole number. So, my question was, how wide is the strip of the map? The strip of the map, that was x, and so we got x to be 4. So, the strip of map showing is 4, what were my units?
Inches.
Inches wide.
Yeah, I did not get anywhere near that.
You had a picture.
I didn't even get the picture right.
Can we see 4
Well,
inches of?
you did. You had it flipped the other way. It just doesn't matter.
Can we see 4 inches of the map? 4 inches of the map is shown by inches.
Yep, that works.
I did 102 minus 70, got 32, and then divided by 4 instead of 8. So I did 20 plus 20 plus 15 plus 15 at 70, and 102 minus 70. 32. So I didn't even have an
Mixture
X.
problems. What the heck is mixture?
Okay.
That's tomorrow, right?
So we have gone through a few problems so far. I don't think I really have, I want to give you some homework time, and I think if I do one more example, you're not going to have much homework time. So if you look on Classroom, I posted 2 things today. One of them is the notes page. The other is the homework. So we have the section 1.6 handout. Your assignment is 1 through 4. So there's a lot of questions on there. You are only doing the first 4. Now, on this, these are multiple point questions. You have to define your variables, whether that's telling me in words or drawing a picture and labeling it. You have to answer with a sentence. So make sure you're doing those things. I'm giving you a lot of class time because I want you